the sort of evolution is from thinking about buildings, the cost and benefits of green buildings. I had the opportunity to do the first large, rigorous study on costs and benefits of green buildings. And lo and behold, it turns out we underestimated benefits, which are large and complex. The focus of this is going to be about climate, but of course the benefits are much larger. And the key is if you can quantify the benefits and add that into a policy and decision making, you can shift from conventional surfaces to what we call smart surfaces. We're going through this extraordinary transition to an unstable, much hotter climate. Here is an example of extraordinary heat in Europe. When you think of Paris, you don't think of 108 degrees Fahrenheit. This is what a conventional city looks like. So dark, impervious roads, so that absorbs the majority of heat. About 90% of that light is absorbed and then re-emitted as heat, which makes the city very hard to walk on and also increases the temperature and air conditioning bill. Impervious parking lots, obviously smog relates to temperature. So you've got these two drivers for smog from a dark city like this, which is temperature and then more air pollution, and similarly with roofs. And so where we want to go, and this is essentially we want to make cities look like cities that Rob has designed, is you take that same city and you overlay on it what we call smart surfaces, meaning very light color, high albedo roads or parking lots. You can go from a conventional dark parking lot or dark roof with a reflectivity of about 10% and go to 70 or 80%. It's a huge difference. I lived in a row house and couldn't stay on the top floor because of summer heat in a dark roof. 30 years ago, I bought special paint, painted it, and it changed the temperature by about 20 degrees on the top floor. You can put on green roofs, and you can see also solar photovoltaic, in this case here on a cool roof or a high albedo roof, here on a green roof. One of the things that does is increases power output because the efficiency of solar is inversely correlated to temperature. So smart surfaces are a set of solutions that allow you to manage sun and rain in a way that reduces costs, increase livability, slows climate. Then the question is, if there are all these benefits, why don't we design cities so they look like this instead of like this? And the answer is that the way that we design cities and make surface decisions is at the agency level. And what agencies like a Department of Transportation does is say, okay, we're going to specify a road and we're going to do that based on lowest cost. And the problem with lowest cost is it doesn't capture benefits like health or air conditioning or air quality or water pollution or climate or equity or risk, all things that are enormously important to the success of cities. And so the purpose of the coalition is to try and move from a dark city to a smart surface city. And there's sort of three big pieces on the boxes on the right. One is you need to move from saying, let's think about each of these strategies separately and organize it into one set of solutions that we're calling smart surfaces, which enable cities to think about it and designers to think about it. Second, build the tools to quantify those additional benefits. And I'll show this a bit later. This includes building an online analytic, very sophisticated cost-benefit analytic engine that incorporates all of these benefits customized to the city so the city can run scenarios. So for the first time, you can actually understand the health benefits, employment benefits, revenue benefits from selecting a surface option that might cost a little more, but where the benefits are huge. And then third thing to drive this transformation is build a coalition. Our work is also international, so groups like Habitat for Humanity or NGOs like WRI, Rocky Mountain Institute, work internationally. We're also working with TERI in India, so the focus is US, Southern Europe, and then India initially. And this set of things we call smart surfaces, or everybody on this call knows them, but just to run through them quickly: reflective roofs or surfaces, green roofs. These are typically 4 to 5 inch trays of sedum or other green materials that insulate the roof and and reduce energy consumption, but also manage water, porous pavements, solar PV, trees, and then combining these solutions. We're working with the National Renewable Energy Lab to quantify the benefits of these integrated solutions. From a climate perspective, this is a substantial impact strategy. So smart surfaces on the left in that blue box, it's a new strategy in this integrated way. It's about a 10% global greenhouse reduction, most of which is increasing the albedo. And by the way, one way to think about this is the scientists in the Arctic are very concerned because as ice goes to water, you go from bouncing most light back to absorbing it. And that's what we're trying to reverse by increasing the albedo of cities. Very low cost on a greenhouse gas per ton reduction. And then if you think about mitigation and adaptation being how do you respond to climate to make sure cities stay livable, this is a very high net present value strategy. So from the two dimensions of climate, smart surface is a big deal. It's a low cost, new, universally applicable, large climate change mitigation strategy. And it's also the only strategy available for cities to become cooler. Going back to this example, if you think of a dark roof, which may be 6 to 8% of a city's surface, or a parking lot, which is on average about 5.5% of the city surface. You have 10 to 15% of the city surface, which is dark, meaning it absorbs about 90% of the heat, which is then re-radiated into the city, and it's impervious. And if you take that and make it white, as I did with my roof 30 years ago, you're instead bouncing the large majority of that heat and light back up into the sky. Most of it exits the atmosphere, and that has a large cooling impact. You're also not then heating up the building and not heating up the city, so you're dramatically cutting your air conditioning load. And of course, the air quality in the city is much improved. When you stack the benefits of smart surfaces, and I've never seen anybody do this before, they look like the following. On the left, we can deliver 5 to 10 degrees average summer cooling. But in addition to that, if you move from a dark pavement that captures all the heat and re-radiates it, we all know what it's like to walk across a dark surface road in the afternoon in the summer. You scurry off of it because you have this enormous amount of heat radiating off the surface. Trees deliver 10 to 12 and maybe 15 degrees equivalent cooling to be able to stand in the shade, and then air quality improves. So you're feeling 15 to 20 degrees cooler if you're in a city that has deployed all of these together. And we're at a time where social and environmental equity and justice is really a big deal. We've seen that with Black Lives Matter. How do you translate that into actual changes in quality of environment? This is a big way to do it. So here's Richmond, one of the many cities that have been mapped by one of our partners. You're seeing an inverse correlation between temperature and income, and that's not a coincidence. For 200 years, immigrants and minorities have been put into areas that are darker. And then over time, the cities have systematically underinvested in them with respect to trees. And then with redlining, it reinforces this. This is a global issue. So let me just go back and make the comment again that the issue here is structural inequality. So imagine trying to raise your kids in a low income area that in the summer is 12 to 15 degrees hotter. How do the kids go out and play? How do you spend time on the street? How do you bike? How do you exercise? It really creates a structural obstacle to quality of life that's endemic to US cities. And we now know how to solve for that. The yellow areas here in India and China are areas that are going to become urbanized. And we can either make it such that those are dark and impervious, or we can make them so that they're reflective and green and pervious. The decision between those two is a very small capital cost difference, but an enormous impact difference in terms of temperature and quality of life. Another example, Washington, D.C., at the bottom right, again, this inverse correlation between temperature and income. The difference is 12 degrees in some neighborhoods, meaning that those low-income areas are darker, more impervious, worse air quality. On the left, using this analytic tool, this is a highly simplified example of it. You're looking at a cost premium for adopting smart surfaces across the 63 square miles of DC of about $840 million over 30 years. The benefits are $2.6 billion. So you have a net present value to the city of about $1.8 billion over that period. A lot of that is in stormwater. There's energy use reduction. Health benefits are large. Climate change benefits are large. And then employment. And this is the first study we did, and one of the lead people for the city pointed out that the report and its findings are influential within DC to enable a city to expand smart surface requirements for roofs, roads, and surfaces. Why is that? Because for the first time, they had the ability to quantify the full benefits. So they've shifted from saying what's the lowest cost to what's the highest value, what's the lowest long-term net cost. That is a transition that all cities have to make, and we've built the tool set to allow that to happen. If you take that analysis and extend it to the US, adoption of smart surfaces over the next 30 years would reduce the country's greenhouse gas equivalent by 10%, would save about $2/3 $1 trillion. It would have huge impacts on health, especially in low-income areas, so it would redress structural urban inequality and create more than 500 million jobs. What's not to like, right? What we're finding is that the benefit-cost ratio of adopting these strategies is typically between 2 and 4 to 1. So it's a very compelling argument financially. And it's just another way of expressing what we all intuitively know. We are drawn to cities like Melbourne because they're walkable, because they're green, because they provide shade, because they integrate life into cities, and recognize that we as humans are drawn to places that are livable and drawn to other forms of life. And so what we've done is captured all that in a very rigorous way with the leading partners to try and drive a relatively rapid global urban adoption of these design strategies as the lower risk strategy, the lower cost strategy, and the strategy that delivers a large set of benefits around health and climate change. So that's my presentation. Look forward very much to questions. You can go to zero net carbon building if you designed it intelligently. Passive House and other designs. I toured a 220,000 square foot building in NREL in Golden, Colorado at 8,000 square feet. It's a zero net energy building. Well, if you can do that at 8,000 feet, you can do it anywhere. And I would say for designers, what that is not a challenge, rather so much as an amazing opportunity to make your work matter in ways that it didn't in the past. Rob's talked about the richness of the Ervik fabric. When we look at his before and after, the first is a place you wouldn't want to go to. The second is you immediately want to jump through his screen into, that he's led the transformation of. So the quality of life is hugely impacted, and then climate. Again, we can do buildings today that are zero net carbon. There's a 2.5 million square foot development in Ecostia that I've been the energy and sustainability advisor on, and we've committed to negative net carbon from operations. So the challenge of climate, the challenge of livability creates a broader responsibility and a broader and larger set of paints to work with. It makes the profession you guys are entering into much more exciting. But you also have more responsibility. And that has to begin with understanding the physical environment, orientation, taking advantage of that, and being respectful of how people live and use that space, how they want to use the internal space, the external space, how those are connected. And you go from dead environments to beautiful, vibrant living environments, and at the same time, help address climate change. And that's a beautiful challenge and a big responsibility. So I hope you all go forth and make the world a better place.